Yeah, I guess part of the link with the measurement forum for us is that we're actually using a lot of the measurement data from other sources. So one particular example that I was kind of discussing during the talk at the measurement forum is with like RIPE's routing information service or route views, where they have these BGP collectors. They're in a sense measuring what kind of BGP data is coming across the internet. And we are a direct consumer of that measurement information, and we use it to see what is the BGP state out there, and we use it as the basis for a lot of our routing status calculations in Dash.
You're listening to Ping, a podcast by APNIC discussing all things related to measuring the internet. I'm your host, George Michelson. This time, we're continuing our series of small recordings made at the recent PIMF session from the APRICOT meeting held in Petaling Jaya in Malaysia last month. PIMF, or Pulse Internet Measurement Forum, is a new community initiative launched by Amreesh Phokeer and Robbie Mitchell from the Internet Society. ISOC want to help grow a community of people who are interested in internet measurement in the widest sense. This episode of Ping wraps up our interviews held at the forum. This time, we're going to hear from Bo Gieskins from APNIC, Doug Madry from Kentic, and Leah Hestina from the RIPE NCC. Before this, to reset context, I'm replaying the recording we heard last time about PIMF from Amreesh, who helped establish the meeting.
Hello everyone, welcome to a slightly different Ping. This time, instead of having one guest and talking at length about a measurement activity, we've put together a package with a number of short recordings of people who attended the first Pulse Internet Measurement Forum, PIMF. So, to kick things off, I've got Amreesh with me here, who has helped start this new cycle of meeting. Amreesh, welcome back to Ping. I think the last time we met, we were in Vietnam, weren't we?
Hey, George. Yes, we were in Vietnam. And I remember we had this very nice meeting under the mango tree. And then in the background, we had the train passing.
That's
and then
right.
We did the recording.
Well, it's a little different this time. We're in Petaling Jaya near Kuala Lumpur at the APRICOT meeting. And you have established a new activity that's meeting at other venues called the Pulse Internet Measurement Forum, or PIMF. Can you explain to people about this?
Yes. So for those who don't know, at the Internet Society, we have the project called Pulse. So Pulse really is a product that produces internet health metrics. So really to give people an idea of how good or how bad their internet health is in their respective countries.
Now, we spoke about this in Vietnam, and it's in the archive of Ping recordings. But to refresh, most people's idea of internet measurement is that it's very focused on technology behavior, packet loss, delay, BGP problems like this or like that. But Pulse is actually quite a lot wider than that, isn't it? It's a measure across a lot of different areas.
It is. And we want to make it more holistic. And also, we want to put data in there that is also relevant to other people than the technical community. Because at the end of the day, the internet is for everyone. And this is what we preach at the Internet Society. And every member of the community, whether they are a regulator, a policymaker, need to find some information relevant about the internet and hopefully be able to produce some actionable items to improve the internet over time in their country.
So there's a community of people who are interested in measurement in the broadest sense in the internet, and the forum is an initiative you guys have taken to sort of bring that together into some kind of collected state, isn't it?
Totally. So we found out that our community is very varied. Again, it can consist of very technical people, but also less technical people, especially those working in the information control space where they are fighting against things such as internet censorship and internet shutdown. And they want to have relevant information on, for example, what are the techniques that governments are using to shut down the internet? And what can they do to protect their citizens against, for example, surveillance? So these are things that we want to talk about in the Internet Measurement Forum. And usually those people wouldn't have a place or a forum to share ideas, I would say perhaps in a secure and safe environment. And this is what we want to provide. On top of also providing insights about the internet of how things are evolving, we also want to give the opportunity to the different members of our community to also bring us their own way of thinking, their ideas of how to improve the internet. And this is what we want the PIMF to be, really an interactive place where people would share ideas and also learn from the whole world of internet data, which is out there and not necessarily very technical, always technical.
So we heard yesterday from Stephen Song, who's based in Halifax, Canada, and he's been working on mapping techniques. Quite a lot of people are aware of the dependency on international transoceanic fibre, but Stephen has been looking, for instance, at the domestic terrestrial fibre maps and the lack of consistency in information gathering over what fibre, what fixed line and broadband services are actually laid down as wires and assets in the ground, and at the structural issues around people coming to government or to civil society and saying, I guarantee you an independent path. But in reality, they might actually be using the same bearer. So that's kind of one side. And then we had other people who were presenting broad internet measurement platforms like Atlas. We had a talk from Bo Jeskins at APNIC about some techniques they're using to do alerting. It's a nice mix of people that are coming into the room, isn't it?
Yeah, it's a nice mix of people, and we want to keep it that way. We want to increase the interaction between the technical people and the non-technical people, because we want eventually the non-technical people to be able to use this information and to design policies that eventually would make the internet a better place.
Meetings are really quite expensive to come to. And in the Asia Pacific, we do have a lot of emerging internet economies where it's a marginal problem. It's quite a big issue for people to invest in coming to what is essentially a fairly small meeting set against all the other things. So is PIMF going to continue to co-locate with other activities for the foreseeable future?
Not necessarily. We are also planning to do one-off events, and that's usually based on the needs of the community. So, for example, recently we got an invitation from India. So we usually work with our chapters around the world. So there is a chapter in India, the Kolkata chapter, who are very much invested in internet measurements.
One of the people who was presenting here is from a community who've built the Indian indigenous platform for internet measurement. I think we might be talking to them later on. So you're kind of saying that if you are in the South Asian community, PIMF might be coming into your space, into a place where it's easier for you to come and participate. It's going to orbit around a bit.
It's going to orbit around a bit, and we want to make it a very localized event where we talk about the local issues and the local challenges and how eventually putting all the data together, we can help the community make better decisions.
So this is a workshop style meeting. You don't yet have a program committee. It's really come as you are and have information and stories to share. Is that right?
For now, yeah, as we just started. So we are, I guess, gathering momentum a little bit. So really understanding what people want and what people would like to hear. But eventually, yes, we want to make this a more structured workshop or forum. So we would, as you mentioned, probably have a program committee around it and also let people tell us what they really want to learn about.
Is the way to participate to actually be in the room on the day PIMF is meeting, or is there another way people can engage in this work?
Well, we have broadcast the live stream and people could also connect over Zoom. But maybe in the future, we will make this a more structured way where people can also interact.
And you're thinking about having an archive of materials. Oh, yeah. There's going to be a web page and associated materials.
It's already on Pulse, the Pulse platform.
And this is a continuing initiative of the Internet Society. So Pulse is an activity of the Internet Society, and PIMF is going to be an activity about Pulse in the context of Pulse of the Internet Society, but in association with other groups as well.
Yeah. So Pulse, as you know, is a project of the Internet Society. And within the project of the Internet Society, we are running this activity, which is our outreach activity, disseminating the information that we are collecting, because usually we might be working on interesting projects about different aspects of the internet, but usually it gets buried into the loads of information that we have on the Pulse website. So the idea is actually to use the research that we are doing and then try to see if this is of any benefit to the community.
So is there a place people can go to learn more about this meeting cycle?
People can go on pulse.internetsociety.org. It's also a newsletter that people can subscribe to, and they will have information on a monthly basis about the different things happening.
Excellent. Thank you, Amreesh.
Thank you, George.
Let's hear now from Bo Gieskins, APNIC Information Products. Bo is a senior software engineer at APNIC and has been working on some structural improvements to the DASH system. DASH is the Dashboard for Network Health, a member service which can show you information about your own network assets. It tracks bogons your network may be emitting in BGP, your MANA's readiness score, and it has information about your origin AS and visibility of addresses in the APNIC HoneyNet system, showing the hits which originate from inside your network. DASH has a system for issuing alerts, and this had some severe scaling issues.
Hey, Bo, welcome to Ping. Can you tell everyone who you are, please?
Yeah, hi George. I'm Bo Gieskins. I'm working as a senior software engineer at APNIC.
So you came to the ISOC Pulse meeting and talked about DASH. Can you just explain to people what DASH is, please?
Yeah, sure. So DASH is kind of APNIC's network health dashboard that we make available to our members at dash8.apnic.net. And their members can do all sorts of things like create alerts to be notified when they have some kind of routing security thing going on, or if they have suspicious traffic originating from their network. It's a place where they can view the MANA's readiness score for their networks, all sorts of things like that. And we're always expanding with new things.
So the Pulse Forum was a collection of people who are interested in measurement, and it sounds like DASH has quite a lot of measurement features inside it. It's a diagnostic tool, but it's also something that can tell you about the current state of your system.
Yeah, I guess part of the link with the measurement forum for us is that we're actually using a lot of the measurement data from other sources. So one particular example that I was kind of discussing during the talk at the measurement forum is with like RIPE's routing information service or route views, where they have these BGP collectors. They're in a sense measuring what kind of BGP data is coming across the internet. And we are a direct consumer of that measurement information, and we use it to see what is the BGP state out there. And we use it as the basis for a lot of our routing status calculations in DASH.
Can you tell us a little bit? Can you give us like the short version of what was the story you brought to the Pulse meeting?
In DASH, when we were calculating routing status initially, we would essentially say, okay, I have these prefixes or these ASNs that I care about, where I want to know if there's a routing status issue. And so I take all of those, and for every single one of them, I'd have to launch out a network request to a series of services which we want information from. So that could be IRRD and Routinator. And in the case of BGP, we had an internal service which was kind of modeling the state of one of the BGP collectors. But anyway, we're querying all these services a lot of times.
Well, if you're running a service for registered members who've said, I want to be alerted of change in my system, it means every hour on the hour in a cron job or something, you're having to go and do these queries repeatedly.
Exactly. And this is what was happening. The thing is, it worked well when there weren't that many alerts, or if everyone who had created an alert only cared about one prefix. But the fact is that people have bigger networks than that.
Really quite significantly large numbers of prefixes.
Exactly.
Each one has to be tested individually.
Yes. And a lot of these services didn't support querying a whole range of things at the same time or anything like that. And because all of them are separate and we have to query kind of a large amount of data and then refine it down to what we actually care about for notifying members about a routing status issue, it was a bit of waste.
It's as if I want to be told if something goes wrong in any part of my routing system, and you get to make one alert that says, tell George when something's wrong in his routing surface, but it involves asking about every prefix George has. And if I've got 100 prefixes, you have to construct 100 queries into the information spaces to determine if one alert message should be sent.
Yep, that sums it up very well.
What did you do to get over a scaling problem here?
We kind of flipped the problem on its head. Rather than saying, okay, we want to look at all of George's resources and see for each of them what the problems are, we just looked at all of the information that is coming out of these services. So in the case of IRRD, you have an event stream where you can get every single event where something is created or deleted. And so for Routinator, they have a JSON Delta endpoint you can query where it give you the entire state. And then after that, every time something is created or deleted. And we kind of created our own version of that for our internal BGP service. And so we would take all of that information and just watch the events that come through. So just as an example, if you get a new IRR route object that comes through, I'm watching that event. And so I'll check it against my filters from all of the alerts. And it's like, do I care about that event that just happened? If so, I know which alerts that it's relating to, and I can do the rest of the processing from there. And it probably sounds a bit complicated, and I find it's difficult to explain to people without showing pictures of it.
But the way I think about this, events are like a stream. They really are like a continuous stream of things moving past. And it sounds like you made the decision to invest in bootstrapping the initial state of everything. So you do one big thing at the start of running this system, and then you watch the stream flow by. And instead of having to consume the whole of the stream and hold all of the stream, you're basically combing out the bits floating in it that are relevant to whatever you have in any of your filters that are the alerts that you're constructing, aren't they?
Yep, that's pretty much true.
And so this changed the cost basis of running the service?
Yes, although maybe not in the way you might think. So there was a bit of an upfront investment in the cost to run these services, which are watching all of the sources. So now we're running 7 BGP adapters to watch all of that information. And some of those need quite a lot of memory to track all of the...
So it's the classic computing trade-off that you can achieve an outcome that works in a timely manner, but you have to invest in the cost of either computing burden or memory burden. There's no path out. It's kind of like CAP theorem, isn't it?
Yeah, I guess. The point is that we pay a bit more upfront, but it means that for the end user, they have a system that works more reliably and actually notifies them.
I think I heard you say when you started this, you were able to run your cron cycle on a really quite tight boundary. You could kind of run almost every couple of minutes or every 5 minutes. But when you'd grown to a certain size, it was taking more than 5 minutes to run one complete iteration of the cycle. So you'd hit a real scaling barrier in the timing limit there, hadn't you?
That's right. And it was kind of bad at one point where it was like, oh, the thing which is processing the alerts is running out of memory because it's doing all these things, or, oh, it's actually launching too many requests to the service, so we have to scale something else up, or lots of weird issues like this. It wasn't even just the fact that we needed to process some alerts every 1 or 2 hours because they were too big. It was kind of burning us in every possible way.
So after you implemented this event sourcing based model, what kind of time boundary did you get back that you were able to run the alert cycle on?
Well, the thing is that we actually don't run an alert cycle anymore.
Oh, there's no cycle.
Right. So for anytime someone is getting notified now in Dash, it's pretty much just because we got an event through in the stream.
So it's triggered by seeing the event happening at the rate you see events occurring on the input side.
That's right. So I think the latency for that is probably within 5 seconds. If we see it in RPKI through Routinator, then within 5 seconds, the user should be getting notified.
Oh, that's a really nice outcome. That's a good deliverable. And you had to build a number of different, I think you called them adapters, to convert the event streams you were seeing into a common representation.
Yes, that's right. So, I mean, while we're doing everything event-based from these sources, each one of the adapters is also writing what it knows to a shared database, because we still do need to query things on demand. So if someone has just created a new alert, and we can't just sit there and wait for all these events to come through. So we still have like a database version of all the things we care about, and we can query that to say, like, for all these prefixes, what's the routing status like? And that's like a pre-prepared, already formatted about everything we care about view of all the routing status stuff. And it's miles faster.
So, Bo, if I understand this right, you're now able to be responsive to an input event that might be only 5 seconds old, but doesn't that present a potential problem if you have a flood of events coming in?
Well, yes. And we did see that, and we've kind of implemented our own thing for handling that. So what we do is when that first event comes in, we'll notify the user immediately so that they have like an inkling that, okay, something is going on. I need to start looking into it. We have like a 5-minute cooldown from there. So any new events that come in, we're kind of batching them together And then after that 5-minute window has passed, they'll get like a more complete notification about all of this has now happened in the past 5 minutes.
So it's a bit of hysteresis and a bit of buffering, and you don't then create a storm of notification events. If I remember correctly, Dash is actually multimodal for output. You can tell people in different ways. They can choose how they're alerted.
That's right. So if you are worried about maybe I haven't seen something yet because I'm still waiting on that cooldown, you can always go to the Dash web interface and you can see the exact current status of the alert at any time.
Thanks, Bo. That's really interesting. And I think it's lovely to see that there's a community outcome of having people providing services like RIS and route views, and then being in a forum like Pulse to talk about both the supply side and the consumer side of those things to produce a measurement outcome.
Thanks, George.
Thank you.
Next, we've got Doug Maddery from Kentic. Doug spoke on Ping last year about RPKI and BGP. We'll get a refresh for the current year another time on Ping, but in the meantime, I spoke to Doug after his talk on a quirk of BGP called AS sets, which has been responsible for some very large route leaks. Doug, it's great to catch up with you again.
It's great to be here.
So here we are at APRICOT at the first PIMF, the Pulse Internet Measurement Forum. Now, usually when we've had you on Ping, you've been talking about RPKI, but for this meeting, you actually brought a different story to the table, didn't you?
Yeah, that's right. So, before we had ROV, our most recent routing security technology, there's some older techniques that are still in use and are widely used today to build filters to try to block inappropriate routes from coming through BGP sessions. And some of those are built by pulling in data from IRR databases.
So IRR, Internet Routing Registry, this is the kind of structural formalism in people who are used to who is in the domain space. It might look like a structured record, but it's actually up to the local registry for that domain space to decide what form it has. There's a few rules, but pretty much it's free form. And ARIN's record of note for asset management, it uses its own structural form that is a type value notation. IRR, now they are built using the notation the RIPE NCC built, RPSL, Routing Policy Specification Language. Is that right?
That sounds right to me. It sounds like you know it better than I do.
So you were looking into this space of RPSL objects that are defined in the WHOIS form, and they're used to construct BGP filters.
Correct.
What's the idea here?
One of the techniques is to use a construct called AS sets. And so, unfortunately, in BGP parlance, we have multiple terms that are overloaded, so have multiple...
Right, so there are two meanings minimum of AS set. Can you explain both of them?
Yeah, so there is an AS set, this AS underscore set refers to this route aggregation in BGP that tries to merge announcements for, I'm not sure the motivation behind it. If you see it in the wild, you see like the little curly braces and AS paths.
The notation that's typically used in the standard view of textual representation of a BGP route has that.
One of the problems with that is that it also breaks the association between which prefix was originated by what AS. You can't use the AS path
right.
The origins.
But that's the one in BGP view, the one that you were looking at.
That's right. That's not the one I was looking at. That's the other AS set. I was looking at the AS set that is a convention that you use to try to aggregate ASs for routing policy based on IRR database information.
So it's when I, as a authorized person in WHOIS, in the IRR data we're talking about, I make a declaration, here are a set of ASs I want to refer to by name.
Right.
And you can use this in many different ways. I mean, the typical way is that you're a BGP speaker speaking to customers who also speak BGP, and you want to construct a set of things that for your purposes you call George's customers. Now, they don't get to decide that they're included in this set, do they? It's my decision.
Yes.
And I could also have a set that was not about customer-facing behaviors. It could be about my immediate peer adjacencies outside my boundary, and I could call them George's peers. And again, they don't have a right to say if they're in that list or not.
Right.
But I'm building these filters, I'm building this information for the rest of the world, and the rest of the world has to know George is going to talk about George's customers and George's peers. That's kind of strange.
What you're describing is a lot of flexibility with this, but also with a lot of flexibility comes the risk of data quality. And that's kind of what I was getting at the talk this week.
Right. So you've been exploring the problems in this space.
Yeah. So I opened with a routing leak that took place, and there's lots to choose from. Of one that involved the perpetrator had an AS set who, if you were to expand the AS set, it included 43,000 ASs.
Sorry, how many?
43,000 ASs.
That's half the total surface of the default free zone
Pretty
at
much,
the moment.
yeah. That's so it's too big. It's not just too big. This causes lots of problems, and it's not the only one. So, with an allow list that's built from an AS set that includes 43,000 plus ASs, you've kind of whitelisted or allow listed, just about the whole internet or a large portion of it, defeating the purpose of trying to, enumerate what are the things that you're supposed to be passing.
So this is quite a common situation when you think about mistakes made in configuration systems. In a way, AS set is kind of like the old idea of a macro. It's a condensed way of referring to a really large, complicated set of things with one term. And the problem is somebody out there built an AS set that had half the global internet in it, and they made an assertion in IRR about that, not really intending to refer to the global network, but for their own internal purposes, thought they were saying something useful. But I'm guessing it didn't have the effect they thought it had.
Yeah. I mean, I don't know the psychology behind how it came to be, but I think what ends up happening is you can include other AS sets in your AS set.
You can nest them?
Yeah, you can nest them. They can be recursive. You can include an AS set that includes your AS set in your AS set. You can imagine I think very quickly people just lose track of what is in the AS set, and it just grows and grows. And I think, there's a motivation that you would like to probably avoid blocking, not including something that you might actually use. So by constantly erring on the side of caution and including more than restricting, these things just kind of grow unbounded.
So Kentic was looking at this. How did you uncover this state? What were you looking at to do this?
I guess I've known about this issue for a while, and I think when I saw this leak pop up, and I check this every once in a while, I'll dig into leaks happen, for everybody who doesn't live in BGP space, they're happening still fairly regularly, but the state of routing hygiene has gotten to a point where they're really not that disruptive, which is good. This is a success.
So route leaks are when people announce things that aren't necessarily truly about what they do, but because they're announced into BGP, the rest of the world acquires knowledge of things that they say they can do, and there's potential for these paths to actually become active, visible paths other people believe they should be using.
Yes, it's a good way to say it. Yeah, it's a routing mishap. And it usually either ends up misdirecting traffic or disrupting.
And the filters, to some extent, are an attempt to say, if I'm listening to you, the only things I'm going to believe from you are the things that I know you said were your customer space.
Right.
And that way, the leaks that might happen from you, I kind of occlude. But this AS set mechanism that would be a way for you to say, Doug's customers, if you misuse it, and if it recursively applies to something else that includes someone else's statement, I could acquire massive amounts of knowledge of belief that you do things. And I would whitelist them, and the filter doesn't do anything useful.
Yeah, it's even worse than that. Aside from it not doing anything useful, there's an expense to it. So this is a lot of data. These things the only way we're going to tackle any of these problems is through automation. And the IR database, for all its faults, enables automation. You can just pull this data down. There's nobody manually making this stuff. You can just programmatically create these, apply these to interfaces. And so we need the system to enable the automation, but there's a cost now. You're pulling down, an enormous amount of data, all of which is going to be useless. You expand this into a router configuration that's over 1 million lines long. In this particular case, if you were to actually apply that to your router configuration, there's a cost to your router.
Yeah.
You're doing this at least once a day, and it's all just defeating the whole mechanism.
Yeah. So it's a classic tragedy of the commons.
It is.
One mistake by somebody doing a configuration design means every BGP speaker consuming this data has an explosion of data cost and of complexity in their configuration, and potentially actually killing their router trying to load the configuration.
Yeah, so I've talked to some cloud operators and large carriers who asked, do you guys still do this? And I'm like, yeah, we have to, but you have to build workarounds for these cases because we're talking about one incident from last year, but there's actually thousands and thousands of AS sets that expand to ridiculous amounts of ASs. So they have to come up with ways to survive.
So the other kind of AS set, there's been a standards process pushing back. Really, the other kind, the BGP AS set, we're talking about deprecating. It's kind of not really the way to do it.
Right.
But this AS set is probably a useful tool if we can put it back in its box.
I think it's going to be with us for a while. We're going to depend on it. I mean, so this is very helpful in the like a adjacency leak or a path leak thing where you have a leak, you have a routing mishap, but the perpetrator isn't originating the routes where ROV might be able to help. ROV can't help in the path leak and like in the incident, the MTS incident from last year, the origins are intact in the routes. That's not the problem. It's a problem that's happening in the middle of the AS path. So, the things that we're trying to do to address that are the ASPA technology that's not out yet, but we're this AS set IRR database stuff, we're going to need that for the time being. And so then I guess my motivation in just bringing this to light, because like I said, I encountered this in my research. I also hear about it, I hear people talking about it, and I've never seen anybody kind of like dig into this. And it seemed like there'd be something positive to just highlight, like, hey, if you are a network and you have an AS set, can you just make sure the contents that are in there, you're being as parsimonious as possible, and maybe even avoiding nesting another AS set inside? Because I'm guessing that's where people start to lose track of what all is in the AS set.
It sounds like the perfect kind of story to bring to something like the PIMF meeting. Other people who are sitting in the room might have ideas around this, tools they could build, ways they could look at this space, look at the problem. It's a nice thing to talk about.
Great, yeah, I thought so.
Thanks, Doug.
You're welcome.
Lastly, let's listen to Leah Hestina from RIPE NCC. Leah is the Community Development Officer focusing on the RIPE tools deployment for the Asia, Pacific and Africa. She is the lead in our region for Atlas, the RIPE NCC measurement system, and has been working on the project since its very beginning.
Leah, how lovely to see you again.
Lovely to see you too, George.
So here we are at the APRICOT meeting, and you have just been presenting in PIMF, the Pulse Internet Measurement Forum.
Yes.
Can you tell people a little bit about who you are and what you do?
Well, yeah, my name is Leah Hestina, and I've been with RIPE NCC quite a while now, since 2009.
Oh, veteran of the industry.
Yes. Yeah, so actually I started at the front office at RIPE NCC, and I keep on moving to different departments, learning new things, and ended up as part of RIPE Atlas team that I really enjoyed and knew back then in the internet industry. So yeah, I really enjoyed all the time that I've been with the RIPE NCC.
So Atlas is something we know a little bit about in our community, but for people who may not know about Atlas, can you describe this project a bit?
Yeah, of course. So RIPE Atlas is an internet measurement platform. What makes RIPE Atlas special is we have many probes connected in different networks all over the world. We have around 12,000 probes connected right now. And what I love about it, what makes me believe in the project is that it's giving access to everyone to this data so that they can measure their network or any network that they want to monitor using all these vantage point that we have around the world.
So the probe is something that RIPE developed itself, isn't it?
Yes, indeed.
It's a small device. I have a very old one, and it's kind of the size of a box of matches. I think the newer ones are a little bigger, but older or newer, little or large, they all fundamentally do the same thing, don't they?
Yes, indeed. They are more or less the same thing. So I think right now we are at the version 5.
5?
Yes. And we also have the software version, which make it easier for everyone, in network operators, especially. They don't have to wait for the hardware to be available, because that's also one of the things that has been a challenge for us, the availability of the hardware. That's why we are now at version 5.
Yeah. So the probe isn't going to take over your network and absolutely flood it with packets, is it? This is a quite carefully designed system for performing measurements. Can you talk a little bit about how the probes measure things?
So when you host a probe, when you have this tiny device, when you plug it into your network, the probe will start connecting to our servers. It will start measuring all the root name servers, and we show the result in built-in measurement graphs. And yeah, so all of these things is available already online.
And it's really just a small amount of traffic that's being sent in the background. But you have this second layer where people who are in the system and who have registered a probe or who've registered an interest can use credits in your system to perform their own experiments. Am I right?
Yes, and that's what makes RapAtlas also special. We have the credit system to make it fair for everyone so that everyone has the same access. And how you can earn credit is by hosting a probe. So, and it's also to protect the system, right? We don't want to overload the system. So yeah, when you host a probe, one probe, for example, you will get around 21,000 credits on a daily basis. And with those credits, you can run your own measurement.
And this is not only to go and probe the root servers, you can probe or ping or trace route or HTTP connect to a number of places, can't you?
Yes, there are 6 types of measurement that you can run with RapAtlas: ping, traceroute, DNS, SSL, TLS, and for HTTP measurement, we only limit it up to, for anchors. So you can use anchors to run
Anchors
HTTP.
are slightly different from probes?
Yes. So anchors is like, we like to call it RapAtlas on steroids. So RapAtlas is a little bit different than the ordinary probes. It attracts measurement from all the anchors that we have connected. So we have around 800.
So this is like a full mesh where the anchors talk to each other, but they also receive measurement requests from the tiny Atlas probes. Atlas probes themselves aren't the targets, and if you have one running in your home network, you're not going to get denial of service attacks into you. You're emitting requests out into the world.
Yeah,
so
exactly.
Hosting an anchor is a good thing to do, but it's something you need to think carefully about the traffic implications. And you say you have 800 of them now.
Yes.
That's huge.
Yeah.
So you have 10 to 12,000 probes and 800 anchors continuously measuring the network. That's amazing.
Yeah, I think that's what makes people interested in RapAtlas anchors, because with RapAtlas anchors, you don't have to do anything, right? You are measured from all these other
There's a
probes.
Continuous flow about the behavior of your part of the network.
And you will learn about how reachable your network is from all these anchors.
Yeah. So in the talk that you gave, actually, I think it was Alistair Strachan from RIPE who presented initially. The RIPE system, as it was described, you showed the map of the world, and you have great density of probes in continental USA and all through Europe and in the Middle East. Asia is a little thinner, isn't it?
Yes, it is. And that's also the reason why I go to APRICOT meetings to meet the community. And, you know, because being here, it's much easier to interact with the RapAtlas ambassadors. We have many RapAtlas ambassadors in Asia Pacific.
Yeah.
But there are still many places, many networks that are still uncovered that we still want to cover with RapAtlas.
So it would actually help a lot if we could get people to get this system running in our footprint in the Asia Pacific region. This could help boost measurement coming from this part of the world.
Definitely, yeah.
But I think, as Alistair said, it's not enough to get one. You've got to plug it in.
Yes. That's one of the challenges, of course. You know, sometimes we meet people. So we have this RapAtlas ambassador running around in meetings, in NOCs, distributing probes. Often people are very excited to hear the RapAtlas for the first time. They got probe, bring them home. And then once you're home, there are many responsibilities that you have to do. You go back to work.
Goes on the shelf.
And goes on the shelf. And that's one of the challenges that we face. But oftentimes they go immediately online. And, you know, like I said yesterday, I met this community from the Philippines. And I thought, like, they're amazing, you know, the support, the willingness to, you know, let's do this now. Let's do this today. And you get this.
It's good energy, isn't it?
Good energy and making you feel like, oh, it's good to be here.
Yeah.
You know.
And the Pulse Internet Measurement Forum is a good place for you to engage. I got the feeling quite a lot of measurements being done in the community actually leverage Atlas as part of the work they are doing. You're like an underpinning for other people to do experiments, aren't you?
Yes, we work a lot with ISOC Pulse. There's a project which is called Mira that Amreesh was presenting on Monday. And that project is using RapAtlas data and MLab. So they're using this pod, the Mira pod, in collecting this data using RapAtlas software probe.
Yes, I hope to be talking with them later on as well. Leah, it's been absolutely wonderful. Thank you for talking to us.
Thank you so much for having me, George.
And if people want to read more about the Atlas project, the URL they go to would be?
It's atlas.ripe.net.
Great, thank you.
Thank you so much, George.
Well, that's all from this PIMF forum, but we'll do more of these when it happens again in our region. If you've got a story or research to share here on Ping, why not get in contact by email to ping@apnic.net or via the APNIC social media channels. Also remember, the measurement@apnic.net mailing list on Orbit is there to discuss and share relevant collaborative opportunities, grants and funding opportunities, jobs and graduate placings, or to seek feedback from the community on your own measurement projects. Be sure to check out the APNIC website for all your resource and community needs. Until next time.